In this video, we're going to talk about a linked list. Basically, an array is a set of similar data objects stored in sequential memory locations under a common heading or a variable name, in this case, array. All of the elements sitting inside this array are of the same data type, and they start with indexing locations at 0, and it grows from there. Linked list, on the other hand, is a collection of data elements whose order is not given by their physical placement in memory. In other words, you can have B occupying the head of the list, C being the one after that, and D being after, but there is no fixed location per se. There is no indexing in linked list. So both arrays and linked lists are data structures consisting of a collection of nodes together. Their behaviors are different, and they differ in terms of their use of memory, their manner of access, efficiency for various operations, and language support. In some languages, you have a complete API encapsulating an array data structure, such as in Java, you have what's called array list, so on and so forth. There's also corresponding linked list APIs and documentations available in Java. And because data are stored differently in these data structures, one involves sequential access and the other one doesn't. Their access patterns are different. And because of the extra use of pointers in a linked list, and there is none in the array, their use of memory and also various operations involving retrieval and insertion of data are different. Since this lecture is about linked lists, let's look at its building block called linked list node. A node is a physical concept that contains both data and a reference to the next node in a sequence. As you know, linked list consists of a collection of nodes, each node having its data and also the next pointer. And this data could be anything. It could be a string, it could be an object, it could also be another class holding a different set of information that you wish. That's what we call node. A node is a self-referential class because what it does is this next is a pointer pointing to another object of the same class. The next pointer inside each node, having the capability of pointing to itself, can create a circular linked list, which could be an infinite loop if you were trying to navigate this list that somehow points back to itself. This, of course, can create an infinite loop. It could be a source of bug. So that's what self-referential node class means. Whereas an array allows you to quickly jump to the location of a piece of data if you know its index, a linked list does not allow you to do that. Most likely, you're going to have to start at somewhere. Let's say if you know the memory address of a particular node, you either go back or go forward. In the context of a singly linked list, whereas this arrow points to only one direction, you have really no choice. You start somewhere and then you navigate forward. Sometimes you may encounter a linked list having two directions, backward and forward. This is what we call doubly linked lists. In order to simplify the discussions of linked lists in this chapter, we're not going to talk about doubly linked lists. So for all intents and purposes, we're going to be using singly linked lists in forward discussions in all of the data structure and ADTs that we illustrate in this class. Let's take a look at the anatomy of a linked list node, referenced by LL node here. This is a public class of generic type T. And notice that the data here, including its next, are protected variables, meaning only files of the same inheritance lineage or in the same package you would have access to. You have a high-level constructor that takes in the info. Presumably, this could be an integer, could be a string, could be something that indicates a uniqueness or whatever data you're trying to store inside this node. And we're setting the next linked to null. And notice that in Java by default, if there's an object that you reference and this object has been declared but not initialized, by default, it should have a value of null. So this is really not necessary. We have access to this method for getting the info and setting the info. These are what we call the transformer or accessor. We also have setLink and getLink as well. Again, these are accessors or transformers. In some textbook references or industry, we simply name this link as next, which is really a pointer pointing to itself or to another instance of the same class. So for example, this node class if you chain this together with other nodes, then you can simply have its own unique information inside each node chained by this next, or in this case, link. And we call these links or next as pointers generically. So once you chain this up, the very last node usually points to null, which means the end of your linked list. And this is really the anatomy of an LL node in this object. We'll keep using this LL node in some code references employed by this textbook. Let's look at some of the examples. The very first thing that we do in order to instantiate a copy of your node is to create it. And we use Java generic by passing in string as your info type and basketball as the value for that information. As node 1 is created with the value of basketball and its next or link being nulled. Then we decide to create another node called S node 2. Again, we go through this construction phase by instantiating a copy of it, inserting another value called baseball as its info into it. The next thing we do is we link both node 1 and node 2 together through use of setLink. And notice that the setLink is really just an assessor for link. And having done that, this establishes an arrow going from node 1 to node 2, chaining both together. So this is an example of a linked list with two nodes, with this very last node pointing to a null as its terminator. So this null terminator is very important in Java. You don't have to worry about it because by default, if you declare something and you don't initialize it, that object has a default value of null anyway. So this is an example of how LL node class could be used and applied to in creating a linked list.